Let's look at number 26. A 5 kg object is propelled from rest at time t equals 0 by a net force F. This bold is signifying that it is a vector, so it's pointing in a particular direction, that always acts in the same direction. The magnitude of F in newtons is given by the function F equals 0.5t. What is the speed of the object at 4 seconds? Okay, so I have a force. It is acting over a period of 0 seconds to 4 seconds, and I want to know what will the speed be at the end. Okay, now you can just think about this more in kinematics terms. Okay, but since this is a momentum unit, what method would you be thinking about solving this? We have a force. We're looking for a change in speed, which is almost like a change in momentum, right? So we have something like F times t equals a change in momentum, so that's our impulse formula, right? But you'll notice we have a function here, right? So this F is changing with respect to t. So I can't just multiply the force by time, okay? Because this is sort of really a delta t. But I have this force and it's changing, and so I can't just straight multiply this force by the time. So I need a calculus way of writing that same equation. So instead of using big block increment of delta x, what would the calculus version be? Be dt, right? So I take this integral of f and multiply by dt. Okay? And so the reason I need to use that instead of just f times t is that I have f changing with respect to t. That tells me I can't just use f times t. Now I want to evaluate from where to where. Right? I'm starting at time equals 0. I'm ending at time equals 4. So that's 0 to 4. Okay? Now this is just equal to mvf minus mvi. And what is my initial velocity? My initial velocity is, remember it's starting from rest, 0. So that will go away. So I don't really have to worry about that at all. Let's go ahead and plug in my function for f is 1/2 t, okay, dt is equal to m is 5 df. Okay, so let's go ahead and evaluate this. Remember, I'm going to add 1 to this, so I'm taking that antiderivative, add 1 to the sort of 1 that's written there. That's normally not written. So I have t squared, and then I need to take this number and divide. So 1 divided by 2 divided by 2, okay, is equal to 5 df. And remember, I'm evaluating from 0 to 4. Okay, so I have 1/4 t squared from 0 to 4 equals 5 df. So let's go ahead. That is 0. T 0 squared, that's just 0, right? So I have 1/4 4 squared equals 5 df. So this will just equal 16 divided by 4. 4 equals 5 df. So df equals 4 meters per second, which would give me B.